Every banana peel, every coffee ground, every leftover vegetable you throw away contains stored chemical energy. Right now, that energy is usually lost in landfills, where it produces methane that escapes directly into the atmosphere. But what if, instead of wasting it, we captured it? Today, we're building a backyard biodigester that turns ordinary kitchen waste into usable cooking gas. And by the end of this experiment, we're going to try cooking a real meal using nothing but the gas produced from food scraps. Organic waste is one of the most overlooked energy resources on Earth, globally. Billions of tons of food waste are discarded every year. When this waste decomposes in landfills without control, it releases methane directly into the atmosphere. Methane is actually over 25 times more powerful than carbon dioxide as a greenhouse gas. But here's the surprising part. Methane is also an excellent fuel. The same gas that causes environmental damage in landfills can actually be captured and burned cleanly as cooking fuel, which means every household trash bin is quietly holding untapped energy. The secret behind this system is a natural biological process called anaerobic digestion. Certain bacteria thrive in environments where there is no oxygen. This is the exact same process that happens naturally in swamps, wetlands, and landfill sites. But if we place this process inside a sealed reactor, we can control it. And instead of letting methane escape into the atmosphere, we collect it. To build our system, we need a container that can safely hold the biological process inside. For this project, we are using Hayden City polyethylene containers. These are durable, chemically resistant, and capable of handling the mild pressure produced during gas generation. The container becomes the main digestion chamber where bacteria break down organic waste. We install two essential plumbing lines. The first is the inlet pipe, where food scraps mixed with water enter the reactor. The second is the gas outlet valve, which allows methane to leave the chamber and travel into storage. But the most important step in building the reactor is sealing the entire system, because the bacteria that produce methane only work in environments without oxygen. Once the reactor is sealed, we need to introduce the living part of the system, the bacteria. To start the digestion process, we seed the reactor with active microbial cultures. These can come from compost, slurry, manure, or other biologically active materials. Once inside the reactor, the microbes begin breaking down organic waste. But to keep the system healthy, we have to maintain the right conditions. One of the most important factors is the carbon-to-nitrogen ratio. Too much nitrogen and the system becomes unstable. Too much carbon and the digestion process slows down. Temperature and pH also play a major role. During the spring season of 2026, outdoor temperatures provide a stable environment where the microbial colony can grow efficiently. As the bacteria digest the organic matter, methane gas slowly begins to accumulate inside the reactor. But instead of letting pressure build up dangerously, we guide the gas into a flexible storage bladder. This gas storage bag expands as methane fills it, and it acts like a natural buffer between the biological system and the cooking appliance. Several safety systems are also installed. A pressure relief valve prevents excessive internal pressure, and an inline flame arrestor ensures that fire cannot travel backward into the reactor. These safety components are critical when dealing with flammable gases. Once methane begins collecting in the storage bladder, the gas can be transported through a hose to a modified kitchen burner. Biogas burns similarly to natural gas, although the flame characteristics may differ slightly depending on purity. When the burner ignites, the methane reacts with oxygen in the air, releasing heat energy, and that heat can be used for cooking. At this point, the entire system becomes a closed loop. Kitchen waste enters the reactor, and energy comes out. Now comes the real test. The methane produced over the past week has been stored in the gas bladder. And today we're going to try cooking using nothing but this reclaimed energy. No fossil fuel, no propane tank, just bacteria and food scraps. When the burner ignites, we see a steady blue flame, and that flame represents something remarkable. Energy that would have been lost in a landfill is now powering a kitchen stove. Systems like this won't replace global energy infrastructure overnight, but they demonstrate something powerful. Waste is not always waste. In many cases, it is simply misplaced resources. If small, decentralized systems like backyard digesters became widespread, households could recover energy from materials that are currently discarded, reducing landfill emissions, lowering fossil fuel dependence, and moving one step closer to a circular economy.